Hello everyone, let's solve this question. X is the uniform random variable varying from -1 to 1. Then what is the expected value of x, x square and x cube? As we know here is that x is the uniform random variable, then it will have uniform PDF, right? This is PDF from -1 to 1. Can you pause the video and calculate what is the value of f naught? If you have, then let's proceed. As we all know that area under the PDF curve is 1. So if you find this area, then it will be equal to 1. This area will be this length times breadth, the or height times length. It is equals to 2 times f0 equals to 1. f0 will be half. So PDF will be half. And you can define CDF, which is equals to integration of PDF from -infinity to x, and which is equal to 1 by 2 into dx from -1 to x. Why? Because PDF is constant half and equals to f0 is half. So if you integrate from -1 to x, it will be equal to 1 by 2 times x plus 1. So CDF is 1 by 2 times x plus 1, right? Now let's calculate the value of expected value of x. From definition, we know that expected value of x equals to -infinity to infinity x time PDF of x into dx. In place of -infinity to infinity, we have defined x from -1 to 1, so we integrate from -1 to 1, which will be equal to x times half into dx. Integrating, we will get the 0. So expected value of x is 0. Now let's find the expected value of x square. First, we will assume that y is equals to x square. We will draw the graph of y equals to x square. We define the range of y. Let's suppose that x vary from -1 to 1. Then y will vary from 0 to 1, right? If you put -1 and 1 in place of x, then you will get 1. So y will vary from 0 to 1. In order to calculate the PDF of y, you have to define CDF of y, which is equal to probability of y less than y. And see this in this way. Let's suppose this is a y. What is the probability that y is less than this value? This is only when x will vary from this to this. Let's find the intersection of this and y equals to x square. You will get minus under root y, root under y. So whenever x vary from minus under root y to root y, y will vary from 0 to x. So this can be alternatively written down as probability of x from minus under root y to root y. And this alternatively can be written as probability of x less than under root y minus probability of x less than minus under root y. So we have to find this probability minus this probability, we will get this probability. Now defining probability of x less than under root y, we all know that this is CDF of x, and CDF of x at a point we define that is equals to 1 by 2 times 1 plus x. Here there is root y and minus under root y in place of x, so we will put 1 by 2 into 1 plus root y minus 1 by 2 1 minus under root y, which will be equals to root y. Differentiating this CDF, we will get the PDF of y, and which will be equals to 1 by 2 times y raised to minus half. Now we can easily define the expected value of y, which is expected value of x square, as integration of y times PDF of y into dy. We already know the PDF of y, and we also know the range of y, which is 0 to 1. We will integrate from 0 to 1 into y times PDF of y, which is this. And once you will do this, the result will be 1 by 3. Now similarly, we can define the expected value of x cube. We will do the same thing, define z is equals to x square, as we all know that when whenever x vary from -1 to 1, z will vary from -1 to 1 as well, which you can see from the graph. If this is this is 1 and this is -1 and this is z value, and so this will be 1 and this corresponding to this value will be -1. So probability of x less than probability of z less than z is equals to probability of x less than z raised to 1 by 3, right? In order to satisfy the condition that probability of z less than z, we have to define that whenever x is less than this value, z raised to 1 by 3, z will automatically be lesser than this value, right? And we already know that this is CDF of x, which will be equals to 1 by 2 times 1 plus x. Here z raised to 3, z raised to 1 by 3 in place of x. Putting this, we will get the CDF of z. Differentiating this value, we will get the PDF of z. Now, similarly, we can find the expected value of z, which is equals to expected value of x cube. Z times PDF of z into dz from minus 1 to 1. Once you will integrate this value, you will get 0. If you have any doubt or suggestion, you can comment below. I will try to look into it. Before ending this video, I have one question for you. If x is the uniform random variable varying from minus 1 to 1, no, 0 to 1, then what will be the expected value of x raised to 4? Thank you.